What's up guys, Onmaths here, and today we're looking at transformations, and first up is Edexcel, and we've got quite a complicated question, aren't they always, and there's lots to do. So this is going to test that we can do a few of the transformations. So it says Carl reflects triangle A in the x-axis to get triangle B, so let's start off with that. So we're getting triangle B by reflecting it in the x-axis. Now the x-axis is this one here. So we want to reflect it in that one, and so for each point we want to jump one for this one and then another one to get it there. For this one we jump 1, 2, 3, so we jump another 1, 2, 3, it gets there. And for this one we do 1, 2, 3, 1, 2, 3, and so it ends up there. So if I just get rid of those, because I think those will probably get in the way, and draw it in. So we've got one there, and then one there. Okay, now we need to label that, so that is triangle B. He then reflects triangle B in the line y equals x. So if I draw in that line, this is the line y equals x. Okay. And this time what we're going to do is count the diagonals. So if I just draw a line in, count the diagonals, and so it's like that. So we're counting diagonally. So we're going to do 1, 2 and a half, half, 1, 2. So the first one will be there. Let's just get rid of that. So it would be there. And we do the same with the next one, so 1 diagonal, 2 diagonal, 3 diagonal, 1, 2, 3, so it will be there. And 1, 2, 3 and a half diagonals, half, 1, 2, 3, so it should be there. Join it up. And let's just get rid of these lines because they'll get in the way. This is the tedious bit. Okay. Let's see if I can get rid of these all in one swoop. Oh, no, I don't want to get rid of that. Do it the long way. There we go, right. And that looks a bit weird. I've drawn that. Oh, there we are. Excellent. Right, and we can move that down a bit. Alright. And he says that that is triangle C. So triangle C. Now, on your exam, you can leave those lines. I think that it's going to get a bit complicated if I leave them. So, if I leave them on this one. So the Amy reflects triangle A in the line y equals x. So she's doing it straight away. So we're going to do the same thing and go count the diagonals. Oh, that's a bit high. Let's do it a bit lower. There we are. Just the same as we've done before, and label it triangle D. She's then going to reflect triangle D in the x-axis to get triangle E. So in the x-axis, and again we're going to do this by counting, so 1, 2, 3, 1, 2, 3, and so that point will be there, and then that one will go there, and then that one will go there. Yep, looks good, and that's going to be triangle E. Amy says that triangle E should be in the same position as triangle C. Is Amy correct? You must show how you got the answer. So, as always with these questions, you must actually write an answer. So, I've done all the working out. You can clearly, well, the examiner can clearly see that triangle C and triangle E are not in the same position. So, all the working out's there. So, I just need to say no, they are not in the same position. Sometimes no would be absolutely fine. The working out on this question is all on the diagram. So I've drawn all the working out. So all I need to do is actually answer the question. And that's something that some students, they do all the working out, but they don't put a yes or a no. And you need to make sure that you have a yes or a no. Next we move on to OCR's offering, and this one actually has a part B and C, but they're nothing to do with transformations, so we're only going to do part A. And it's all about enlarging, which is one of my favourite, in fact my favourite transformation. Maybe translations are pretty high up there. So it says the centre of enlargement is minus 1, 5, so let's just plot that on. That'd be the first thing you do. And the scale factor is a third, which means it will actually go smaller. Now you might be familiar with this, you might not, but the way of doing enlargements, the way of drawing them, is to join up each of the corners of the shape, vertices of the shape, with the centre of enlargement. And each of those points, so this point here, this point here, and this point here, will shift towards the centre of enlargement. So the distances that are on there now, we're only going to plot a third of that. And there is an easy way of doing this, especially when it lines up nicely, is what you do is you go from the centre of enlargement to each point and you count how many squares you go to the right, how many squares you go up, right? So I'm looking to go to this point here. So we're going to count. So 1, 2, 3, 4, 5, 6 to the right, 1, 2, 3 up. Okay, so 6 to the right, 3 up, and I shouldn't have done those as dots because it's going to take forever to get rid of it. So if it was 6 to the right and 3 up, when it's a third of that, instead of 6 to the right, it will be 2 to the right. And instead of 3 up, it will be 1 up, right? So it actually ends up being here. If you do the same to the next one, I'm going to do this as a line this time. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 to the right, and then, as we can tell, 3 up. So instead of 9, it will be... Instead of 9, it will be... I'm just dragging things now. But it will be 3 to the right, and then 1 up. So we're going to go 3 to the right and 1 up. And it will be here. Now for the last one. So 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right, and then 3 down. So instead of 9 to the right, it will be 3 to the right because it's third, and then 1 down, so it would be here. And then join them up. And there we are. Now it sometimes says label this with B, this one doesn't, so that's absolutely fine. Now what you could do is you could get a ruler out and measure it, and measure the amount of centimetres between each of the points, and then divide it by 3. That would be fine. Just make sure if it's like slightly off a square, almost always these questions will be on the square. So what I mean is kind of like that, rather than like that. Okay, and sometimes you get questions that they're halfway, something like that. Okay, but they're never going to be really complicated. They're not going to be like a third of the way like that or something like that. Okay, so if it looks very close to like a point like that, or a half a point like that, then it probably should be. So just bear that in mind. Last up is our AQA question, and this one's got quite a lot of things to understand in it. It's actually quite a simple question, really, because it says that a rectangle A is put onto rectangle B by a single transformation. Now, what I would do here is think about what the transformations are. Okay, so we've got reflection, we've got translation, we've got enlargement, and we've got reflection. Rotation even. Already got that one. Rotation. Okay, those are the 4 transformations. So for this question, Javed's saying that it's only reflection, that nothing else works with it. So it's just kind of process of elimination. right, let's have a think. So has it been rotated? Well, if it had been rotated, let's see if I can do this. I haven't actually tried doing this, but let's give it a go. So if this was rotated, oh wow, this actually works. It would look like that. Okay, it's not a square, and that doesn't look like that. Okay, so it's definitely not been rotated. Okay, so we can eliminate that one, and let's just get rid of that. So it's actually the same way up, so it's not been rotated. Let's try this again. If it had been enlarged, we know this, that it would change size, right? Okay, but if you look, that's exactly the same size. So definitely not enlargement. The last thing is transformation. Now transformation means we draw out the shape, badly, and we just move it around. And so it can go down there, or to the right, or here. Well, hang on, that works. Okay, so it actually has been either reflected in the y-axis, yeah, that's fine, that works, or it's been translated. So we've got to figure out how it's been translated. So we can safely say, no, he's not correct. And normally with these questions, no is the answer, right? And we could give a little bit more explanation. Okay, so you pick the same point on both shapes, and you start at A, and you count how many jumps to the right. So 1, 2, 3, 4, 5, 6 jumps to the right to get to the same point. So it's gone 6 right. So we need to write that down. So it could have been translated. And why not actually show the correct translation? So like 6 to the right and 0 up. So we show it like that. Now I'm sure this question you could have just written translation, perhaps. And actually, those astute among you might realise that I was wrong when I said it couldn't have been rotated. I've just realised that it could have been rotated 180 degrees across 0 and 2.5, because that would restore it to its same way up. So actually, yeah, you could have written down rotation. I think translation was way easier, but always be aware that normally with these questions, normally the answer is no. They're looking for you to find a kind of different way of doing it. So just bear that in mind. Okay, next one. So this one, CDE, which is this one here, is mapped onto PQR, which is this one here, by combining 2 single transformations. So we're looking for 2 transformations, right? The first is a rotation of 90 degrees anti-clockwise about E. Now what that means is that E is the center of rotation. When it says about E, it's saying about that position, and the position of E is that where I've just put a little cross. So it's got 90 degrees anti-clockwise. So let's try and draw the shape in as best I can. Okay, and normally you'd use tracing paper for this. Okay, so 90 degrees anti-clockwise will end up being like that. Okay, so when you get your tracing paper, you put your pen out where the center of rotation is, and you just move it around 90 degree anti-clockwise. So if you start here, 90 degree anti-clockwise would end up with the arrow looking like that. Okay, right. Now it's saying that there's 2 single transformations. We've done one of them, and we've got to describe fully the second transformation. Now this has been enlarged, but it's also been flipped. So you might think, well, it needs to be kind of maybe a translation up here, and then we reflect it, and then we enlarge it. But that's not what the question's saying. The question's saying there's a single one. So when something's been, when something changes size, it has to have been enlarged. So we might as well write that down now, because we know if there's only one transformation left, it needs to have been enlarged. Okay. but we need to describe it more. I mean, it's worth 3 marks. You're not going to get 3 marks just for saying that. Now, when something gets flipped, it means it's been enlarged by a negative scale factor, okay? So, when we're drawing in the lines like we did before, this one's easy because these two are definitely the same point, okay? They're like the end of the triangle. But P and Q have been kind of flipped around, and that's the only thing that could explain, you know, the fact that the whole shape has been flipped around. So P is actually the bottom of this smaller shape. Let's try and get that a bit better. There we are. So P is actually there because it's been flipped around, right? And Q is actually, if I can draw it properly, Q is actually that one there. Okay. So the center of enlargement is here. It's that position there. So with center -1, 0. Now we need to know the scale factor. Scale factor is easier to work out. So and scale factor. Now whenever the ray lines have to go back through the center enlargement, it's always going to be a negative, so we might as well just write a negative there. We know it is. And if you just count the squares, so on this bit here, so 1, 2, 3, 4, 1, 2. So it's going from 4 to 2. No, it hasn't. It's gone from 2 to 4. Could do it the right way around because we're starting on this shape here, and we're going to PQR. So it's gone from 2 to 4, so it's going to be scale factor 2. And that's a fully completed answer. Wow, not too difficult. I think recognizing the negative scale factor is difficult, but then again, that's why this is question 21 on a higher paper. It's not supposed to be easy. But whenever you have a change of size and it doesn't look normal, because if you had like a shape like that, I don't know. If you had it like that was really bad. Let's try that again. If you had it like that, where they're both pointing the same way, then it's definitely going to be a positive scale factor. But you can see straight away that if you used a positive scale factor on this, it's just going to end up looking like this, for instance. Probably haven't done this right, but it would end up looking like that if you just had a positive scale factor. And so whenever you have a shape kind of flipped around a little bit, always think, right, it's probably going to be a negative scale factor. And I think the one of the mistakes you can make is joining Q up with this bottom one. But if you see here, if you did that, they would never cross over. You wouldn't be able to find where the center enlargement was. So maybe a bit of trial and error with those to figure out actually all 3 ray lines need to cross at the same point. So just making sure we match up the right ones. Anyway, I hope you found today's video useful. If you did, please click like. If you want to see more from us, we release videos every single weekday, Monday to Friday at 9 o'clock in the morning. So click subscribe and click that bell to make sure you are kept apprised of the latest videos. Also, we've got a website, onmaths.com, which I'm sure you've gone to. If you haven't, there'll be a card that magically appears above now, full of completely free resources for you to try out, and hopefully they help you with your maths going forward. Otherwise, thank you very much, and we'll see you on Monday.